Hello and welcome to part 2 of this two-part video on the tracheal system of insects. In part 1 we looked at the more simpler tracheal systems and we used the larval stage of the darkling beetle. In this video we're exploring the more complex tracheal systems found in advanced insect species, for example that of the wasp.
I'm going to be saying that we're looking at the tracheal system of an adult insect, using as our example a yellow jacket wasp, Vespula vulgaris. We've got two 3D volume views of the wasp head, thorax and abdomen. These now are sagittal cut plane views again of head, thorax and abdomen, and this is a view from above, and if you freeze the video you can read the script and the names of the structures. Now the whole point here is that we want to delineate the tracheal system. So the first thing we do, and now we're just taking the abdomen of the wasp, and the first thing we do then is to use Tomo mask to reverse all the attenuation values. So this is in fact 8-bit data. So what was black is white and what is white was black. And just as a result of looking at the default value, you can already see these large abdominal sacs. The 10 written on them is just because that's the nomenclature that Snodgrass uses in his honeybee papers. Now here, although we're seeing some of the tracheae, particularly the tracheal vessels joining the abdomen with the back of the thorax, we're not seeing these other vessels very well, but as you'll have guessed, by moving the windows and levels, the rest of the tracheal system becomes progressively easier to see. So here we've moved a little way along, here we've moved a long way away, and now we're seeing the system much better. This is air in the crop. Now if we cut into this from the other side, now we have what I call a double contrast, and now that we can see that lateral trunk so much better, despite the fact that we have still got white air surrounding. This is a view from above at an optimal windows and levels. So here are the large abdominal air sacs and the rest of the system with the lateral longitudinal trunks, and these are some of the levels at which the spiracles enter. Remember that with a wasp the first spiracle is the propodial one, which is actually in the thorax, so the first abdominal confusingly is the second. By using a combination of the three sagittal, transverse and coronal views in some software like Dissect and the multiplanar format, you can follow along any particular tracheal vessel or any particular sac and see basically where it goes. You can also use a 3D cut here at the level of the fourth abdominal spiracle, and again you can see exactly the same pattern that we saw in the much simpler caterpillar and mealworm, with a spiracular branch, a longitudinal branch, and branches going up to the heart and down to the ventral nerve cord and going transversely into the gut and the reproductive system. These are just the other spiracles. The 8th spiracle in a wasp you can't normally see because it's in the sting reflex. Now, if you want to get rid of all the air surrounding, and also, for instance, air that's in the sting recess, or air that's trapped between the plates, the tergal or sternal plates, there are a number of different softwares that one can use. And by doing this, here we're gradually getting the tracheal system exposed. And here we have it completely exposed, and we'll look again at the finished version, as it were, at the end. So that is the adult wasp's abdomen. This now is the head and thorax, using the same technique with the numbering equivalent to Snodgrass's honeybee nomenclature. Here's a cut plane view through those large indirect flight muscles, and you can see all these little tracheal vessels going in between. The flight muscles are, of course, the most metabolically active tissue in the body and need a very healthy blood supply as a result. These are just other views, and I'm going to rattle through these and get you to look at them at your leisure, and I'll just point out one or two features. This is a view from above, and I'm going to now be cutting in, and I particularly want to look at the tracheae that pass from the first thoracic spiracle into the head. So there it is, spiracle 1, and as we cut down a bit further we will see the tracheal, the air supply to the head and brain. We're also incidentally seeing the propedial spiracle, which is the first abdominal. So here we're at the level of the upper two trunks going into the head. Here we're rather lower. I want you to see the tracheal vessels in the antennae. These little round rings are artifacts. Here now the trachea going into the legs. You can also see the pedicular ones. These are the ones going through the wasp's waist. We've already seen it from the other side, from the abdomen, and these are the all-important spiracles connecting the air supply of the thorax and head to that of the abdomen. This is a full frontal, as it were, and we're going to cut into this, and we'll see the surround of the brain and some other structures as we go. So this area is the brain, surrounded by a very healthy air supply. Cutting further back still, we're seeing the air sacs within the mandibles, and we're also seeing the air sacs in these powerful adductor muscles to the jaws. Here we're looking from above. These three neat little holes in the top of the head are where the three simple eyes, the ocelli, pass. If we cut down now, we're seeing the upper of the two vessels passing into the head, the upper two cervical tracheae, and these are the lower two tracheae. On a future video, we're going to be looking at this structure, which is called the nasal pouch. Here is a side view, a sagittal view of the upper and the lower cervical tracheae passing into the head, and again the red arrow is looking at the nasal pouch, and more of that anon. So in summary, normally there are two easily seen tracheal vessels passing through the wasp's waist, connecting the thoracic and abdominal systems. Normally these tracheae feed into what is designated sac 10 by Snodgrass. We couldn't see Snodgrass's sac 9. We were able to identify all the abdominal spiracles. There were two and not one, as Snodgrass suggested, tracheae on each side supplying oxygen to the head. I strongly recommend you read this article, which is referenced because this gives a very good discussion not only of tracheal systems of insects, but all the available software packages. In my view, the best way to delineate the tracheal system, whether it's an adult or an immature insect, is to reverse the data and then segment out the tracheal system. And by using a 3D view like this, one can get a very good idea of structure